Hey guys, Miss Anselmo here with a video tutorial on atomic structure and periodic table. We'll start with the structure of the atom. As you see here in this picture, there are two major segments of an atom. The first is the inner portion of the atom, which is called the nucleus, and then surrounding the nucleus are the electrons. An atom is made of three basic parts: protons, neutrons, and electrons. As shown here, protons and neutrons are found inside the nucleus, while electrons are found surrounding the nucleus around the outside. Sometimes the outside of the nucleus is called the electron cloud because the electrons are rapidly going around the nucleus so fast that they almost form a cloud of electrons. Atoms are made of three basic parts: protons, neutrons, and electrons. Protons and neutrons are both located inside of the nucleus, whereas electrons are located outside of the nucleus. Protons and neutrons each have a mass of 1 AMU. AMU, remember, stands for atomic mass unit. And all that means is that each proton and each neutron has a significant mass, whereas electrons are 2,000 times smaller than a proton or a neutron. So their mass is not even considered when we discuss the atomic mass of an atom. Additionally, each subatomic particle has its own charge. Protons have a positive charge, neutrons have no charge, which we call neutral, and electrons are negative. When drawing an atom, we always include the protons and neutrons in the center, which again is called the nucleus. So protons, which are positive, and neutrons, which are neutral, are located on the inside of the atom. Since protons and neutrons both have a significant mass, most of the mass of the atom is located inside of the nucleus. We also include our electrons on these various levels, which we call electron shells or energy levels. Electrons don't like to crowd up the same space, so they organize themselves into these electron shells. And the rules are that the first electron shell closest to the nucleus will hold up to 2 electrons. Each additional electron shell will hold up to 8. When you look at a drawing of an atom, the electrons that are on the outermost shell are known as valence electrons. When you're considering different types of elements, we can use the periodic table to determine the number of protons, neutrons, and electrons. Each element on the periodic table has several pieces of information showing. On the periodic table, at the top of each element is the atomic number. In the middle is the element symbol. Beneath that is the element name. And at the very bottom is the atomic mass. One thing to remember is that we're always going to round the atomic mass to the nearest whole number. If you're asked to find the number of protons in an atom, that's the easiest one. The atomic number is the number of protons. In fact, the reason boron is atomic number 5 is because it has 5 protons. So anytime you're asked to find the number of protons, just look at the atomic number and that's your answer. Finding the number of neutrons is a little bit more tricky. In order to find the number of neutrons, we have to subtract the atomic number or the number of protons from the atomic mass. Remember first that we have to round our atomic mass to the nearest whole number. So for this example, the atomic mass of boron would be rounded to 11. Since the atomic mass is equal to protons plus neutrons, we can subtract out the number of protons and we end up with the number of neutrons. Therefore, boron has 6 neutrons because the atomic mass, 11, minus the atomic number, which is the number of protons, 5, is equal to 6. So in boron, there are 6 neutrons and 5 protons, and that's why it has an atomic mass of 11. Finding the number of electrons in a neutral atom is also easy. The number of electrons will always equal the number of protons in a neutral atom. For every proton, remember protons are positive, there should be a matching electron. For example, if there is an atom that has 5 protons and 5 electrons, the atom is neutral because the proton's positive charge will cancel out each electron's negative charge. So let's try another example to make sure that we understand how this works. Here is zinc. At the top of the box, we see the atomic number for zinc is 30, and the atomic mass for zinc is 65.39. The first thing I might want to do is make sure I round this atomic mass to the nearest whole number. Since the number to the right of the decimal is a 3, we can assume that the whole number mass would be 65. So, to find the number of protons, we just look at the atomic number. The number of protons will always be equal to the atomic number. So, zinc has 30 protons. The number of neutrons, remember, is equal to the atomic mass minus the atomic number. So to find the number of neutrons, I'll have to do 65 minus 30, which gives us a total of 35 neutrons. Now for electrons, we're going to assume that this is a neutral atom, and if it is a neutral atom, remember protons are positive, so if there are 30 protons, we also need 30 electrons, which are negative. If there are 30 protons and 30 electrons, the atom is neutral. There are 2 exceptions to these rules. The first one is ions. Ions are atoms of the same element that have different numbers of electrons. Another example is isotopes. Isotopes are an exception because they are atoms of the same element that have different numbers of neutrons. Because ions involve a change in the number of electrons, ions result in a change in electrical charge. Remember that a neutral atom has an equal number of protons and electrons. Protons are positively charged and electrons are negatively charged. So when the numbers are even, all of the positive and negative charges cancel each other out and you end up with a neutral atom. However, when an atom loses an electron, it becomes positively charged. If you look here at this example, we have a sodium atom on the left and a sodium ion on the right. On the left, we see that this is a neutral sodium atom because sodium normally has 11 protons. And if we count the number of electrons here, we would see that there are 11 electrons. 11 protons and 11 electrons result in a neutral atom. However, if one electron gets lost, here we have the sodium positive 1 ion. Now we have 11 protons, but only 10 electrons to cancel out, which means we have 1 extra proton. Because there is 1 extra proton, the charge of the atom becomes positive. Remember that an atom does not become positive, does not become positive by gaining protons. Atoms never gain or lose protons. An atom becomes positive if it has lost an electron. In this example, we look at what happens if an atom gains an electron. On the left, you'll see normal neutral fluorine, and on the right is a fluorine minus 1 ion. Fluorine normally has 9 protons since its atomic number is 9. On the left, we see that there are 9 protons and 9 electrons, so that's a neutral atom. For a fluorine minus ion, we add an extra electron. So in this example, we have still 9 protons because that number doesn't change, but now we have 10 electrons. Since we have an extra electron, the overall charge is negative. With isotopes, the number of neutrons changes. So if an atom gains neutrons, the overall charge stays the same because neutrons are neutral. But one thing that does change due to the gain or loss of neutrons is the atomic mass. Remember, neutrons do contribute to the overall mass of an atom. So if an atom is gaining neutrons or losing neutrons, the atomic mass will change. Here we're looking at several examples. We have normal carbon on the left. In the middle, we have carbon 13 and carbon 14. Remember, this number next to the isotope name doesn't mean negative 13, but the 13 represents the atomic mass of the atom. Normal carbon has a mass of 12. So when I want to figure out the number of protons and neutrons in normal carbon, the number of protons is equal to 6 because the carbon's atomic number is 6. And to find the neutrons, I do 12 minus 6, and I end up finding that it's 6 total neutrons. However, for carbon-13, since this is an isotope, the number of protons is still 6 because the atomic number of carbon will not change. It's still 6. But the number of neutrons, again, I take my atomic mass, which is now 13, and I subtract 6, and I find that carbon-13 has 7 total neutrons. Same thing here with carbon-14. The number of protons stays the same, but the number of neutrons has increased because now I take my new atomic mass of 14, subtract out my 6 protons, and I get 8 total neutrons. So when you're dealing with isotopes, remember the number of neutrons is changing, and because the neutrons are changing, the atomic mass is changing as well. We also learned about the periodic table. Remember that the periodic table is organized by atomic number. So each element has its own special place, mainly because of the atomic number that it has. Additionally, we learned that elements are also placed into groups and periods. Elements that are in the same column are considered part of the same group, and elements in the same row are considered part of the same period. The organization of the periodic table goes beyond just families and groups. When we looked at the periodic table, we saw that there was this zigzag line on the right side. In class, we learned that that zigzag line meant that there was a separation on the periodic table. To the left of the zigzag line are all of the metals. One thing to keep in mind for some questions would be that most elements, if we look at the periodic table in its entirety, most elements are metals, and those elements are on the left-hand side. To the right of the zigzag line, we have our non-metals. We see that that's a much smaller group of elements. Right along the zigzag line, we have a special group of elements known as metalloids. Since the metalloids sit on this boundary between metals and nonmetals, metalloids are known for having properties of both metals and nonmetals. Another group that we found important is this last group to the right. We call it group 18, which are known as the noble gases. And remember, the noble gases are a special group of elements because they do not bond with any other atoms because they all have complete valence shells, which means their outermost electron shell is completely filled. Also keep in mind one exception to the metal-nonmetal rule. In general, metals are on the left of the zigzag, nonmetals are on the right, but one exception is hydrogen. Even though hydrogen is on the left-hand side, we do count it as a nonmetal because of its properties. Going with the metal and nonmetal theme of the periodic table, we also learned about the properties of metals and nonmetals. Some properties of metals include a shiny metallic luster. Metals are also malleable and ductile. They are often good conductors of heat and electricity. All metals are solid at room temperature except for mercury. And all metals show a silver-gray color except for gold and copper. Nonmetals, on the other hand, are dull, brittle, which means they break apart easily. They're poor conductors of heat and electricity. Nonmetals also can exist as all three states of matter at room temperature. So some nonmetals are gases at room temperature, some are liquids at room temperature, and some are solids at room temperature. Nonmetals also vary in color. That's all for periodic table and atomic structure. Thanks for watching.